chamada também.
Legal, legal.
Foi.
Bem, boa noite a todos. Primeiro, gostaria de agradecer a presença, tá, de vocês que estão aí assistindo esse evento, obviamente ao moderador e aos palestrantes aqui presentes também. Lembrando que esse webinar do SPE, tá? Nós vamos ter 12 ao todo, abordando resiliência dos projetos offshore. Bom, meu nome é Mauro Nunes, eu sou o vice-presidente da seção Brasil do SPE e estou aqui justamente para apresentar a vocês esse webinar sobre resiliência dos projetos offshore. Isso vai ser o 8º webinar, né? Se você não está nos acompanhando, você poderia muito bem assistir os outros 7 que já estão aí no YouTube. Então, nesse 8º, vamos abordar a otimização da construção de poços, tá? Vamos ter como moderador o senhor Carlos Alberto Pedroso, que ele é o Master Complete Engineer da Enauta e é o presidente da SPE Seção Brasil, tá? Só lembrando a todos que no final a gente vai falar sobre a filiação, que é muito importante esse problema da filiação no SPE. Inclusive tem vários descontos e a partir de setembro já entra como afiliado para o ano que vem. Então, por favor, fique até o final. Tá ok? Bom, Pedroso, muito obrigado pela sua presença. As palavras são suas.
Obrigado, Mauro. Obrigado à assistência, a todos que estão nos assistindo. Também muito obrigado aos nossos panelistas, ao Gleber, Ramon, o Andy e o Garcia. Nós vamos tratar de um tópico extremamente interessante, que é o poço do futuro, se é que é do futuro, não do presente, né? E eu gostaria de iniciar falando até sobre este tema. Quando o Fernando Machado me convidou para ser o chair e o moderador desta sessão de otimização da construção de poços, que é um tema que realmente eu domino bastante bem, eu fiquei pensando, puxa vida, do que é que nós vamos falar, né? A indústria evoluiu muito nas últimas 2 ou 3 décadas na construção de poços. Nós diminuímos o tempo, aumentamos a eficiência, aumentamos a segurança, adequamos os poços cada vez mais, fizemos muito. Então, do que falar exatamente? De novas tecnologias, de novos materiais. E daí eu pensei, eu acho que a nossa última fronteira é a digitalização, é a transformação digital, é a construção do poço 4.0. E daí isso é muito interessante, que remete exatamente para o que a gente tem chamado de transformação digital. Alguns anos atrás, quando eu fui apresentado a essa terminologia, né, de transformação digital, internet das coisas, inteligência artificial, aplicado à construção de poços, eu pensei, bom, isso é irreversível. Não existe possibilidade disso não se tornar uma realidade muito em breve. Inclusive, né, quando eu lembro que eu falei assim, isso vai ser igual ao celular. Daqui a 20 anos a gente vai olhar e vai falar assim, poxa, mas em algum tempo a gente já fez poço de forma diferente, a gente já viveu sem celular. Então foi exatamente essa ideia que eu tive. E isso sempre ficou, digamos, vindo como um tema recorrente para mim, a importância desse tema dentro do SPE. E, por conta disso, esta diretoria, né, quando eu assumi, eu criei exatamente a diretoria de transformação digital, convidei o Gabriel Serrão, que é gerente de transformação digital dentro da Petrobras, para assumir essa diretoria, visto a importância desse tema. Então, eu acho que, junto com a neutralidade de carbono, que é a ordem do dia, a mudança, a transformação, né, da energética do mundo, a transformação digital é o terceiro tema de muita importância, né? Então, foi por isso que nós decidimos criar essa diretoria, dada a importância desse tema. E foi por isso que eu resolvi trazer este tema para a construção, a otimização da construção de poços. As apresentações serão em inglês, visto que 2 dos apresentadores falam inglês e teriam um pouquinho de dificuldade de acompanhar o nosso debate em português. mas sintam-se à vontade para fazer perguntas e comentários em português, que nós traduziremos para a participação no webinar. Então, sejam muito bem-vindos. Obrigado mais uma vez pela presença. Let's switch to English. Thank you, everybody, for coming. This is the 8th webinar of the SPE webinar series about resilience of offshore projects, and we'll talk about well construction optimization. And we know that reducing costs and increasing efficiency in well construction is vital to the resilience of offshore projects. Much has been discussed and done and applied, and the advancements of well construction over the last few years is remarkable. I can say that a lot of these innovations has been discussed in our SPE events. I can remember some years ago, Renato Pinheiro presented a new management process for well construction that reduces the time by half. He was awarded in the regional award by that. In this webinar series, we could see Priyanji talking about the TOT 3P, that is ultra slender well. We come from the conventional well, slender, ultra slender well. It was discussed in the 2 weeks ago. We also had the opportunity to know the bonsai tree from Shell. That is a small Christmas tree with half of the width. And if it's not awarded by the technical innovation itself, it has to be awarded by the creativeness of the name, because bonsai tree is really very creative. And we SP talk about intelligent completion, open hole intelligent completion, new materials, nanotechnology, everything. But I really think that we achieve a technical limit. Now, I believe that the next frontier, if not the last, is an evolution that cannot be postponed. That is an integrated digitalization of the entire well construction. I believe that all bottom hole geological and mechanical drilling information has to be sent from the platforms and will be analyzed with advanced digital technologies and artificial intelligence. In fact, it has been done. A week ago, Philippe Blanchard and Isabel Waclavec talked about the DrillX from Total. That is artificial intelligence applied to deep water drilling to anticipate any kind of risk, to increase the safety of drilling. So the idea of this webinar is discuss the well of the future, the well 4.0, the web well, and everything related to this. So we call 2 operators, Petrobras and Equinor, and a service company that integrated this kind of service and the rig side to talk about a case that is going in Brazil in peregrino fields. The first presentation will be delivered by Gleber Teixeira, that is a data scientist and technical advisor from Petrobras. He's a philosophy doctor and a friend of mine for the last 20 years, I believe. Gleber, welcome, and the floor is yours.
Okay, good evening, everyone, and thanks for coming. Thanks, SP, for the invitation, and thanks, Pedroso, for the gentle introduction. In fact, I'm very proud to be here. My name is Gleber, and I work at Petrobras. I will do a very brief overview about some topics related to well construction optimization and well 4.0. As you can see, the process of building a well involves several interconnected steps. I mean, starting with the design of the well, passing through the analysis of related well, and going on until the execution of its construction. In drilling and completion stages. These steps, until recently, were done using some modern technologies and tools, but they were essentially manual processes. However, nowadays, it's changing with the advent of what we call Industry 4.0, or more specifically, in our case, well 4.0. This terminology, in general terms, represents the widespread and interconnected use of emergency technology such as digitalization, automatization, IIoT, wearables, AI, cognitive computing, big data, and so on. Everything, of course, applied in well construction activities, among other things, to optimize the process as a whole. For it to be possible, research, development, and of course, adaptation are necessary. So talking about adaptation, I would highlight some topics, as we can see in the screen, to have this well 4.0 or all these things together. We need adaptation in the hardware. And I mean infrastructure, rig adaptations, tools, remote operations, and so on. Of course, we need, moreover, software adaptation to supply condition to have a pipeline in AI, machine learning, computer vision, stream analytics, and so on. Moreover, we need the project design adaptation, and of course, the main drive here is the people adaptation, as we will discuss further. Please, next slide. So we don't want to use new technology because it's built for funding, but because it can reduce costs and increase efficiency, operational efficiency. So as benefits are related here, we can see increased operational efficiency, as we said, cost reduction, man-hour optimization, reduce human risk exposure, of course, decreasing the offshore personnel and optimizing logistics issues, more robust planning, training improvements, speed of information, and also decision sharing. All these things together we can see as a benefit. Next, please. Here I try to synthesize many areas of the well 4.0 that we are studying or implementing there in Petrobras well construction and in the present and in the future. We are talking about high-speed communication and IIoT, edge computer, new protocols. We are talking about the transmission from the rig sensor to the onshore, to our decision rooms. Here we can see the RTO Live. That is a kind of software that we implemented to plot dashboards and supply the people onshore to take decision and remote monitor. We're talking also about some prototype that we have done using smart contract and blockchain technology. Remote operation as well. We have tested some situation with mud logging, water lines operations, LWD, MWD2, stimulation boats, and so on. All these things together, we seems in the future to have autonomous operation. Is a process, is a step-by-step. We want to reach this step that is autonomous operation in the future. To reach there, we are studying and implemented AI and machine learning algorithms based on historical data that we are getting from the sensor through the RTO Live software. We are implementing these mechanisms, these algorithms to supply autonomous operations in the future, and we hope so. In the future, we could make it happen. Next, please. Here I am showing the decision support center in Petrobras, as we are testing remote monitoring and also remote operation, and maybe in the future autonomous operation. I'm gonna show a very brief video to show you some of the developments that we are ongoing projects in Petrobras. Here I am showing the RTO Live that brings all the data sensors from the rigs. Here is our prototype of smart contract using blockchain technology, emulating the Ethereum blockchain. We are emulating send the monetary unit from the contractor to the blockchain and through the third part company. It's of course is a prototype, it's an emulation. Here I am using the Ethereum blockchain to record all the transaction. Here I'm showing you a system that detected oil and gas seepage, oil and gas leakage. Another system that detect movement using computer vision, movement in the wellhead to see how much it's movement. And here is a project that we are showing a system that evaluate of all the beach abrasion, the max drill depth based on lithology area, beat model, and many parameters based on machine learning algorithms that we trained with historical data from our database. And the last one is a video showing the S3MS, that is a partnership from our research center, SEMPES, in partnership with UFMG, UNESP, Instituto Eldorado, for detection of personal using or not PP. Just a brief commentary about the video that we passed, that image that show you the oil leakage in the seabed was provided from by Professor Bing Wang from University of Missouri. They provide us to test our algorithm that's still in development in UFF, Universidade Federal Fluminense, and also the Projeto Reis in Petrobras. Another software that I'm showing to you is about design automation. In fact, is a well-designed platform that we call PostWeb, and we want to provide in the future all the automation and intelligence layer to perform all the steps of the design well, based on the simulations, based on historical data, and so on. It's an ongoing project that we are developing in Petrobras. Next one, please. I have just 1 minute more. Sorry, because it's so fast. The time is very short. Talking about real-time data analytics, we are developing the PWDA with E3S in partnership with E3S. It's a real-time drilling problem detection software based on digital twins algorithms to support real-time decision. And here in the picture, we are showing when the software detects indicating a possibility of washout, and we pull out the string and we detect, in fact, there was a washout in the string. And next, please. So finally, what do you expect from well service provider and the driller contractor? We can highlight this main issue. New technology, of course, I mean, at cost reduction, communication protocol agreements, for instance, with XML, Modbus, MQTT, REST API, and so on. Another point, very important point, is the training and qualification of employees. We are not talking just conventional employees, for instance, in petroleum engineer or chemical engineer. We are talking about new data skills and new jobs. For example, data scientists, data engineers, IIoT technicians, blockchain developers, and so on. And finally, contractual adjustments, of course, to make it possible. And all these things, of course, we keep an eye every time in the improved safety conditions and improve to avoid problems during operations. So my final remarks is we need to have resilience to be competitive in the current scenario, as Pedroso said in the beginning of the event. So finally, thanks again to SPE and Petrobras for the opportunity to be here, and thanks for everyone for your attention and patience. Thank you.
Thank you very much, Gleber. It was a very nice overview about the well 4.0. It's interesting that this kind of words, I believe that in the near future, they will be so common as today is RIG, BOP, and BAJ. I believe that the digital twins and web well and artificial intelligence will be words that we will use IoT, as you said, and we will have to change the technician for the IoT technician, the engineer by the data science technician, engineers, and everything like that. So very interesting, and mainly also some points about the future of this technology, this smart contract, this edge computing, the automation of the drilling as we think that it's possible. Very interesting. Thank you. So now we will see the point of view of an operator. I will ask Ramon Matos, that is the program manager of Equinor, to talk about the point of view of the operator about this total well delivery, as Equinor call this technology. Ramon, welcome. The floor is yours.
Hello, can you hear me?
Yes.
Okay, good. Good evening, Mauro, Pedroso, Andy, Carlos, and Gleber. Good evening to everyone that are listening to us today. Hope you are well and safe at home. Thank you very much, Mauro and Pedroso, for the nice introduction. Thank you all in SPE for organizing the relevant series of webinars. I joined some of the other panels and I was impressed by the importance of the discussions. I want to compliment SPE for the event and for stimulating such debates. I'm truly honored to be invited and come here to share some of the initiatives that Equinor has been working on the digital area, focusing, of course, on the well construction optimization. It's an important thing we are going to discuss today because, as said, efficiency in well construction is vital for the future projects in our industry. And you see that this has been embedded in our digitalization strategy. Strategy is key because the digital transformation forces companies to rethink how execute the tasks, how to develop new business process, management practices, and and information systems. So in this context, let's get started. I hope you find this session interesting, engaging, and informative. I see the slide is not in the full screen. Is that okay? Okay. Can I move on down? Hello? Could you please put the slide in full screen, Pedroso? It's hello. Can you hear me?
Oh, yes. Let me see if we can fix that. Oh.
That's okay. Good. Thank you. That's it. So I intend to go through these three main items, and I start giving you an overview of the digital strategy in Equinor and how optimization fits into that strategy. So then I move to the second topic, narrowing to automation in drilling well, which I'm sure it will draw our attention to the main initiatives that to optimize well construction optimization. And finally, our case in Peregrino Phase 2 called Total Well Delivery. My idea here is to briefly touch upon in 15 minutes presentation and give enough time for good discussions and questions. Okay, next, please. I would say that every great achievement starts with a good plan, right? So here I show you what Equinor believes in regarding digital strategy. Just by labeling ourselves as the digital energy company gives an idea of our ambition on this matter, right? On the left side, you see the three main items of the corporate strategy, and on the right side, our digital directions. Always safe, high value, and low carbon are the base for our digital enablers, including well optimization. In a nutshell, Equinor wants to have information available all the time, easily accessible, reliable information whenever is necessary. We also want to improve our safety through digitalization, and robots can make it easier, not only on safety, but in all spheres and areas of our organization. And last but not least, the entire company has to change. It's not about implementing new technologies. It's about changing the way of working, changing people's mind. Okay, so we can move on. Going deeper in some of the initiatives on these big digital fronts that I have just mentioned, Omnia is definitely one of the most important because it will be our cloud-based solution where all applications are supposed to be connected and will enable, as written in the slide, seamless access to relevant data across scenarios and disciplines. Omnia is not only fundamental to all systems in Equinor, it also integrates information drilling well. In addition to Omnia, there are other projects which will also improve our data availability, right? Equinor has been working on projects that give transparency and accessibility between sources of data, especially with reservoir and subsurface information that are critical to the well planning process. These are some of the important steps to have the data available anytime, anywhere. We can move on. We discussed in the last slide the projects in light of data availability. Here we go for digital initiatives that makes our operation safer and consequently optimized. The operation planning tool is a good example of how to predict and prevent safety incidents. It brings together information from several areas and to give the possibility to have the best safety decision and be also one step ahead of security threats. It can be considered our flagship for this category. In drilling well, avoiding exposure of people to falling objects, in the red zone is key. Industry has seen some casualties on drill floor lately, and there's a considerable number of drop objects inside of the red zone. So this system automatically detects people, alerting crew if it's at an unwanted location, and also objects through this stick-up high detection. So it's one of the initiatives for the well optimization inside the drilling well department. So next slide. This group that I must admit I like most. There are so many initiatives on the robots, Have you had the chance to see the video from the world's first logistics operations with a drone to an offshore installation? It's not, it's very interesting. There's a video on YouTube, you can check it out. A drone flew a piece of equipment from an onshore installation to an offshore installation in the North Sea. Shoreway platform. It was a distance of 8 kilometers, quite far. This is just a recent example, So we believe the robot will make our lives easier and greener. As saying here, the autonomous unmanned assets keep our people safe and reduce our carbon footprint. For drilling well, there is a roadmap for the best utilization of robots. There are many fronts being developed. You see in the future. And then you can pass, we get to the end of the strategy. As I said, the digital path has to be built by people with the right competence. And that's why we have been investing in training of our people to get them acquainted with all of these innovations. 50,000 digital learning sessions is a remarkable number achieved by our digital academy. In drilling well, for example, the rig simulators training the crews with the newest technologies on shore. It's one of the initiatives. And having one of these simulators in Brazil dedicated to Peregrino Phase 2 project. So if you go ahead, in sum, I believe we were able to see that the digital tools is a key enabler in securing efficiency, value creation, well construction optimization, and it's making everyday life easier. In this slide, this is the way we want to materialize digitalization in Equinor. The most important points are here in summary, but we highlight the 3 main projects for well construction. Just click, please. And I intend to talk a little bit more this digital well planning, ADC, Drilling Operations Center. You can go ahead. So as I said, the first big chunk is the automated drilling control. The ADC is done by development of automation of systems that are responsible to feedback from the well. It allows drillers to automate repetitive drilling activities, such as making connections, define specific parameters for circulation, weight on beat, and more. There are several activities. It's connected to the main rig equipment, such as the roll works, top drive, and mud pump. And by real-time visualization, it brings to surface some downhole conditions, especially if in conjunction with wire drill pipe. The second one, that's now showed now in the slide, if you go back, is a big development, is the onshore operations centers. Personnel allocated will apply real-time data in a more structured way than before. They will use advanced monitoring equipment based on data from the drill strings, and in some rigs using wired pipe. And the third prioritized initiative is the implementation of digital well planning. For Peregrino, we are going to use this solution from Schlumberger, the drill plan. It's key for us in drilling well, it's quite based to be efficient in planning the wells. So a good and robust tool will definitely help the operators to achieve this goal. So moving on, I mentioned several times Peregrino. You can go ahead. One more. Yeah, I mentioned several times Peregrino in this presentation. Even though prior to this slide, I was trying to cover the digital initiatives in Equinor as a whole. Here I give you a flavor of the Peregrino field. First oil was in 2011 with proven reserves of approximately 400 million barrels. we reached the 200 million barrels produced last year, a big milestone. To who don't know, Peregrino has two fixed platforms tied to one FPSO with capacity of 100,000 barrels a day. For the second phase of Peregrino, we will bring one more platform. Actually, it is already here in Brazil. The first oil is planned to 2021, and it will add around 300 million barrels in reserves for the field. With this mention to Peregrino phase 2, we can go on. With this mention, I can connect well to my last slide, where we have a partnership with Schlumberger in this project called Total Well Delivery. The expectations on total well delivery model is quite high. We understand that this represents an opportunity to make a step change in performance for HSE, cost, and efficiency. You know, as one of the reasons for the project, some efficient improvements that Equinor has implemented in past have been flattening out now. So the TWD success is important because with this structure, with automation and digital enablement, and also combined with this multi-skilled crew, can help us to improve consistently on our drilling operations. Total well delivery, it's not there yet. Just a second. Total well delivery was possible mainly because of the full integration of services and scopes, and including the drilling unit that's provided by Cameron. Contract has almost a full scope on the well construction, going from the rig equipment to drilling services. So it's a new project. The rig has a mechanized pipe handling system upgraded with automated drilling control. The fluid system has remote operated valves and instrumentation installed on the main routings. This is just to give you some examples of automation installed in the equipment offshore. These new installed hardwares aggregate with condition-based maintenance supported by the new digital platform are promising for this project. And when it comes to this digital platform, that stands for all initiatives that we have discussed in this presentation. But for well optimization in Peregrino, ADC, drill plan, and drill ops are the most important, and they will connect well to give that digital platform. So finally, the last and factor and one of the most important is the commercial model. I know that was built to promote the continuous improvements from contractors and give them subsidies, to deliver the best performance. The contract is based on a lump sum per section with performance bonds aligned with the operational strategy. So that will give the possibility to invest in technologies and have that commercial alignment. That's what I had for today. And again, thank you very much for the invitation. And it was a pleasure for me. I enjoyed being here and speak about it. Carlos, I then hand over back to you.
Thank you very much, Ramon. It's very interesting to see the integration of Equinor towards this digital transformation. You mentioned something that is allowing the information to be available for everybody. That is what I have heard, that is removing the silos of the information and its need. If we want to drill a well, we have to remove the silos. The information have to be available for everybody. Also very interesting, the use of the digital solution for safety. This is one of the best utilization of the digital transformation, safety of all the process of well construction. So very interesting. And well, and all the points that you touch that will be covered for Andy and Carlos about the modifications in the rig and all the integration of the process that we need to have this kind of solution. So thank you very much. I would like to call Andy Peters, that is manager of Schlumberger, and he's working in the Peregrino project together with Equinor to give us the vision of the service company, the integration of service with the operator and the drilling contractor and the service company. Please, Andy, you're welcome.
Thank you very much, Carlos. And I'd like to thank Mauro and Carlos for the introduction, and also the SPE for the opportunity to present here to you today, and also Gleber and Ramon for their presentations and setting the scene, as you were, for what I'm going to present here. So next slide, please. Equinor, back in 2018 now, awarded us a contract essentially to overcome the challenge that they have that you see here on the screen. We've spoken about how to sort of optimize performance or be resilient, and the best way of being resilient in the oil business these days, given the oil price, is reduce the length of the amount of time it takes to drill a well, because in the drilling business, as everyone here is acutely aware, time is money. And therefore, if you can reduce time, you reduce the costs of what's going on. Some of the challenges that Equinor saw that was basically causing a plateauing out of the efforts and the industry efforts, frankly, in lowering the well cost further, is essentially the number of stakeholders involved in a contract. The more interfaces you have between different companies makes sharing of data harder because of different protocols, different ownerships of sensors, different processes, and simply communications. If communications go wrong, then mistakes are made, and mistakes cost time, and time costs money. So reducing the stakeholders is critical to having an efficient operation. Ramon touched on it here as well in terms of the commercial model. It's no good if the service company is being paid a day rate and something breaks down on the rig. Then many service companies still get paid their day rate, while the operator, Equinor in this case, Petrobras as well, are still paying money out to everyone else to sit around, basically, while somebody else fixes a problem. So commercial alignment will provide the appropriate motivation in order to think as one team and for everyone to act together, frankly, with the same objective in mind, which is drilling wells cheaper, faster, and safer. And also scalability. You know, how do you drill increasingly complex wells without scaling up the number of services or the number of people required to do that? And as has been touched on by everybody before, these days everything is about data, and data management needs to be optimized. So if we can click on the next slide, please. The model that we come to here for the Total Well Delivery project is essentially to align the commercial model between ourselves and Equinor. As Ramon said, we're on a lump sum per section drill. If we take longer to drill, then we just absorb our own costs and we lose a bonus. If we drill the sections efficiently, then Equinor saves money by reducing all of their other daily costs. And we share in their performance gain by earning a prorated bonus depending on the amount of time that we save. We've developed workflows which are all data-driven for the project, which I'll touch on later. We have an advanced crew model in that under this contract, Schlumberger are providing both the rig crew and the majority of the services on the platform, which allows us to cross-skill, multi-train people to help each other out on the rig. So, you know, the rig crew can assist the services crew when they're rigging up and save some time. And the services crew can help the rig crew on occasion to overcome whatever challenge they may have, because we all work for the same company. There's no intercompany rivalry or issues that get in the way. We've developed fit-for-purpose downhole systems and sensors, which I'll come on to later on. And also we have an integrated hardware platform which allows us to combine data from both the downhole sensors from the bottom hole assembly, but also all the surface sensors on the rig, because we also have provided the rig equipment and the rig sensors. So if we can move on, thank you. Next one. So essentially, we have a new concept here, and the concept is designed around 4 pillars that all are required to be successful. We have a mechanized and automated drilling rig, and Carlos, after me, will go into more detail on what that is and how that works. A personnel model, which I've touched on, about integrating and synchronizing the drilling crew and the drilling services crew on the platform to work as one team with Equinor themselves on the facility. So it's a harmonious relationship to get things done, and we're all motivated in the same way to achieve the same goals. We have a digital workflow for both well construction and well design, which again Ramon touched on here, called Drill Plan and Drill Ops, which I'll explain shortly. And this is all enabled by being awarded the full scope of well construction services, which is one of the points I initially touched on, to reduce the complexity, reduce the number of stakeholders involved in drilling a well, and reduce the communications interfaces. You know, Ramon and his team there in Equinor work through me and my team, and we have a very close relationship and on day-to-day matters and work in a coordinated way to prepare the platform ready for drilling. Okay, if we can go to the next slide, please. Thank you very much. Okay, so as you can see here, we have an end-to-end architecture. And I should just point out before I talk to the slide, you know, time is money, but time isn't just about being fast. Time is about being efficient, but efficiency comes from many things. Obviously, reducing non-productive time is primarily driven by reliability. There's no point being quick if then something breaks and we'll sit around for a few days to fix it. That touches on something that Ramon mentioned about condition-based maintenance and basically preventative or predictive analytics and preventative maintenance, using sensors on the rig equipment that Carlos will talk about to make sure that we know when it's going to fail before it fails, so that we can plan preventative maintenance into the well construction process, so we stop things from breaking without taking more time to drill the well. And it also comes from reducing invisible lost time, which is the lost time that's there that isn't necessarily obvious or visible. It's not necessarily non-productive, it's just efficiency gains. Most of drilling a well isn't actually about drilling faster. It's not about rate of penetration or ROP. A lot of time is spent tripping in and tripping out, especially as wells get longer, deviated and more complex to drill. And tripping in and tripping out is about doing the same exercise of making or breaking a pipe in a very consistent way. It's no good having one makeup connection in 1.5 minutes, 90 seconds, if then we take 2.5 minutes or 3.5 minutes for the next connections. So it's about consistency as well as reliability. And consistency isn't something people are good at, because it's repetitive, people switch off, they don't focus, they make mistakes. And therefore, to achieve consistency, really what we're going towards now is automation and systems orchestration, so that the computers take over to do repetitive tasks. And drilling a well is mainly a sequence of repetitive tasks. So as you can see here in our well construction architecture, typically, the operator, Petrobras, Equinor, have enterprise systems, lots of offset data. They know where the risks are in drilling a well, have all the geological information. We bring that into our planning process we call Drill Plan, which is a digital well construction process. It integrates building a well, has simultaneous real-time cross-checks for things like hydraulics, cementing, mud, the BHA design, shock and vibration, torque limitations, all these sorts of things, so that we can design a well that can be efficiently drilled. Again, you can't be efficient if the well plan you've got makes it difficult to drill in the first place. There is then an interface, which is a digital interface. We can essentially squirt this digital drilling process into the drilling operations environment we call drill ops, which then allows us to orchestrate and automate the rig equipment to then go and drill the well. So we design wells we can drill efficiently, and then we drill the well we've designed with as much automation as possible to remove the human inconsistent element to the process. And then we monitor, we provide advice, and we provide control over those rig systems, both on the rig, but also by beaming all of the integrated sensor data from downhole and surface sensors onshore. We can have people dispassionately looking at the rig as it's drilled 24 hours a day, 7 days a week, and providing real-time guidance back to the rig, the driller and the other rig team to identify things that Gleber mentioned in his presentation about washout detection, how to minimize shock and vibration, stick slip, those sorts of things, which all tend to cause pipe fatigue, BHA fatigue, and downhole failures, which causes NPT, which adds time, which costs money. We also have an interface then between the drilling operations system to the rig control system itself, which on this particular project we also have provided, as Ramon mentioned. And that allows us then to have direct control, automated digital control of the draw works, of the top drive, of the mud pumps. So we can automate the RPM of the drill string, the weight on bit, and the flow rate of the mud, which are the three primary control mechanisms you have to drill and steer the well. So that we can then drill the well we've designed without surprises through integrated sensors with 24/7 monitoring and control. Next slide, please. So here's how it's going to work in practice. On the left is drill plan, on the right is drill ops. We work with the asset team, our in-house engineering team in Equinor's office in Rio de Janeiro. We plan together with them and ourselves, doing fluid hydraulics, cement plans, BHA design, etc., and come up with a digital drilling plan. We send that digitally offshore to the drilling offshore environment, where we sit with the company man and the fluids engineer, cement engineer, directional driller, mud logger, etc., in a collaboration center, one room with everyone sat in it on the rig that's been designed as part of the platform design here. And then the driller can either take manual control or allow the computers to take over and drill the well. The well knows digitally the plan, it knows where the BHA is, it knows where it's supposed to be, it knows what all the drilling parameters should be and what they are, and then it adjusts things to drill the well automatically that we have designed, with visibility in town of all of the data from all the sensors combined, feeding back in a fast loop to the driller to identify issues and give guidance on performance improvement, and a slow loop that returns back into the planning phase so that any lessons learned and best practices from the current well are built into future well designs to allow us to have continuous performance improvement from one well to the next. Next slide, please. So drill ops, multiple parts of this. I'm just going to touch on orchestrate, automate, and advise, which are the things to synchronize our activity, increase consistency, and optimize performance that I've mentioned. Next slide, please. So orchestrate, I'm not going to talk through the details of this. You can read it as I'm going, but it allows us to standardize how we do things, tripping in, tripping out, BOP tests, whatever it may be. The system actually knows how to drill a well, so it adjusts the individual building blocks of well construction, puts them in the right order for us, and then instructs the computers and through that the rig equipment to perform those activities. So it can trip in, land on bottom, break circulation, start drilling, put ROP on the drill bit, drill ahead, and all automatically without the driller actually having to do anything, because it knows how to do that sequence of activity. And it will move all the surface equipment on the drill floor in parallel together And as a result of this, things are safer because we have to therefore remove people from the rig floor and completely automate the rig floor and create a red zone entirely. Next slide, please. It can also automate reporting and tell us what it's doing because it's doing everything. It knows what it's doing. We have the automation side of things here. I've already spoken about that. Basically, we have a digital drilling program. It knows how to drill a well. It tells the equipment how to do so. So it can ramp up the pumps, tag the bottom, deal with friction factors, mitigation, stringers, shock and vibration. It can even program downlinks, change directional control of the BHA, deal with top drive stalls, washout detection, stuck pipe detection, immediate response to that rather than relying on the driller to remember what to do, for instance. It's a little bit like a GPS. You tell it where you want to go, it figures out the best route and gives you the instructions, or frankly now takes over the controls of the car and steers you to your destination, and you as the driver are just sat back watching, making sure that things are going as they should do. Next slide, please. And then drill ops advice. We gather all the sensor data, we show it to the driller, we show it to our operations team in the collaboration center, we beam it onshore, we monitor it 24/7, we identify areas for performance improvement, reliability improvement, consistency improvements, feed that back to the rig or feed it back into the drill plan so that we design wells with these efficiency gains built in for the next time that we drill. Next slide. So to finish here, what have we got? Digitally enabled operations to optimize well construction, automation of hardware, sensors, software, and then both the services crew and the crew themselves, all from the same service company. Automated workflows, automated drilling activity, cross crew support on the rig, so everyone helps everyone else out, motivated to perform in the same way with the same drivers that the operator is trying to achieve, to reduce drill time, improve safety, improve drilling performance, reduce non-productive time, invisible lost time through consistency improvement, drill the well we design, safer because we remove people from the rig floor, let the computers drill the well. It's faster, lower cost wells, simplified operation. And I think that was my last slide. So with that, I will hand it back to Carlos, and then Carlos Garcia will take you through details of the rig itself and how we actually put what I've just explained into practice. Thank you, Carlos.
Thank you very much, Andy. Well, you talk about the heart of the process. I believe that is all the 6 points, that is the commercial agreement, the workflow, the crew model, the downhole fit for purpose tools, and the hardware of the platform. So all the integration of this complex environment is, I believe, is the heart of the operation, together with the automation of the rig and the ways to send it to onshore and treat all this data. So let's see now the point of view of the rig side, talking about all the modifications in the rig and in the training and the crew that we need to implement this technology. Thank you, Andy. Please, Carlos Garcia, the floor is yours.
Hello, Carlos, can you hear me?
Yes.
Okay, so first of all, I would like to thank SPE and Carlos Alberto for this invitation. It's a pleasure to talk to you about this subject. So I will try to narrow it down to some of the aspects that in Schlumberger, the division I work for is RMS, which is Rig Management Services, which basically is a drilling contractor services. But today the focus has shifted more to providing, instead of providing a rig with a workforce, we're also providing these systems not only for the operators but drilling contractors which are interested in installing these systems in their rigs. So we'll talk about the workforce organization, and then I will talk to you about condition-based system. On the picture there of the Peregrino platform on the right, I have signaled in blue the limits of what we call the DPU, which is the drilling package unit. So in summary, the contract that we have with Schlumberger as far as the drilling contractor services, which is part of the Schlumberger total well delivery scope, is to manage the drilling crews for the DPU, provide the maintenance crews as well offshore to do all the maintenance tasks on that DPU. And then we provide support on procurement and warehousing of all the spare parts which are needed for this maintenance. This is in summary the scope that we have in this project. Next slide. So Andy talked about the 4 pillars that we have for the success of the TWD contract. So which are the mechanized and automated drilling rig, personnel, digital platforms, and then the scope of all the well construction services coming together. And we're just one of them, right, in this project. So on the mechanized and automated drilling rig, is important to remember that we are not providing a rig which is belonging to us. It's an asset that belongs to Equinor. So this is a significant change in our work scope. So the DPO equipment commissioning and acceptance process is a very important one, because it's a time when basically the operator, Equinor, ourselves, and the OEM, which is companies like Cameron, which is also a Schlumberger company, and Siemens, all the companies that have provided the equipment, get together, check that all the equipment is duly performing, all the COCs are in place, and then when all this is checked, it will be handed over for us to manage this equipment. The next one will be the maintenance team. Sorry, if you can go back. Yeah. The maintenance team competency is very important for us to be sure that they're trained, and since they come from different backgrounds and they have been brought together for Peregrino project from different backgrounds, we are training, getting them ready to understand this new asset and manage it appropriately. Then we need to train the drilling crews competency to be able to operate this automated rig DPU. Next comes safety. As part of our personnel, ourselves and Equinor are fully aligned on making safety the #1 priority. And this will be achieved, first of all, on the automated side of the rig. We have the advantage of being able to have all the red zones without having personnel having to intervene, and this makes operation a lot safer. This has to be planned in advance, so we're having on part of the training before we start operations a review on making sure that all the red zones are properly taken care of, and we don't put the people in harm's way. Additionally to that, we need to train the drilling crews on their jobs, on the client requirements, our own internal requirements, and all the Brazilian regulatory requirements for operating. Executing the grid maintenance is also important. And on the last subject, I will touch how the CBM, we're going to be evolving from a preventive system, which is time-based, to condition-based monitoring. So here on this slide, you see the operations, the organization. Most of you might be familiar, there are others not, but this is a typical drilling contractor organization, both onshore and offshore. What I have highlighted there is in dark blue will be positions where we have changes to a typical drilling contractor operation. And in this case, you can see the onshore operations planner is a function that now is under us, since we are in charge of helping all those services coming together in the DPU operations. And you will see another operations planner offshore, and the tool pusher also being responsible for the well site coordination of these services. On onshore, we also have a CBM engineer, which is remotely located on the OOC. And then we have the maintenance manager, an HSE manager, and a workforce coordinator. On the offshore organization, it's similar to a typical drilling contract organization, but again, we have the drilling team, which is a driller and his team, which are shaded in amber. All of them will be cross-trained in performing services such as directional drilling, wireline, and cementing operations, so that when the services companies come to the platform, they are ready to help to run these operations alongside the lead engineer for that operation. And another position which is very critical for us on the organization is electronics and instrumentation technician, being that the platform has a lot of automation, and we're going to have also a data system supervisor. Next slide. On this slide, you can see maybe what is, for me, one of the most important training sessions that we have for Peregrino Sea. And here you can see on these pictures the Macaé simulator. So you can see these are two driller's chairs, which are simulating the same driller's chairs which are offshore. And you have all the monitors. And in this sessions, the drill well on simulator, all the aspects of drilling the well are run through these simulators, so that everyone which is going to be part of the offshore drilling teams are familiar of how the equipment is operated, what troubles they can expect, and prepare for the operation. So it's something quite new and quite unique for us to be, and quite challenging to put in place. So I would say that this is key for the success of the project, is to have these drill well on simulators done. And we have 8 of them planned. 2 of them have already been done. They were suspended because of the COVID-19 situation, but it's a key training for the success of the project. Now going into condition-based maintenance. So to explain roughly what this means, typically the drilling contractors' maintenance programs consisted of time-based maintenance, where you have an equipment which every monthly or quarterly or 6 months or yearly has different tasks on that equipment. The purpose of any maintenance program is to reduce MPT and optimize the maintenance costs. And basically what the CBM proposes is the same objective, but it will give us more resources to be able to optimize this. So you can see that the deliverables for this is equipment health status, optimized maintenance execution, and the simplified recertification, which I will talk about later. But on the right on the diagram, you can see on the top what a typical non-CBM maintenance looks. So the green barrels means the productive time. Basically, that's when the platform is either drilling or producing. And then you have an event, which is a breakdown of an equipment. And at this time, you will go into MPT, where you have red money, and you have resources dedicated to solving this breakdown. And at the same time, you stop your drilling or your production. If you make the comparison to the CBM model, during the time that you're drilling or producing, you will have a lot more data being analyzed, and this will give you a prediction of you can estimate when an equipment is going to break down. So this is going to be flagged in a way that you can plan for this maintenance to happen before it actually breaks down. And then on planned maintenance, I think that there's a lot of gains as well. Typically, for example, on the major equipment like BOPs, you have like the main tasks which are regulatory or for the OEM side required to be done every 5 years, for example. Today, you already have a lot of the drilling contractors delaying these tasks for 10 or even more years. But the way they have managed to get this approved is only by means of having a condition-based maintenance program in place, so you can show that this equipment after 5 years it still does not need a major overhaul. And this is a big advantage for everyone as far as not being necessary to stop the rig and cause unnecessary downtime. Next. This is an overview of the workflow or of the CBM workflow. So you can see there on the bottom left the main equipment on a rig, and through inspections and telemetry you will gather data. This data then is securely transmitted to a cloud. In Schlumberger, this is a Schlumberger Azure cloud. Once it's in this cloud, we use analytical software and artificial intelligence to process this data, and then this after processing, we'll be able to see the results on a web portal and through internal reports. This is shared with the maintenance crew, and the maintenance crew will then check the first deliverable, which is the health status of the equipment, and then they can recommend to optimize the maintenance execution, which will be deliverable number 2. Once this has been decided, it will be communicated to the Equinor team, because the SAP is a system under which the maintenance is run for Equinor. So once this has been decided, through planned worked orders, this will be the SAP maintenance procedures will be changed, and we arrive at the third deliverable, which is after we have been running this CBM for some time. We will be able to see and measure how effective the CBM program has been. On this slide, you can see the equipment that has been chosen to start off with on the CBM maintenance system. So we'll start off with 3 main equipment first, which is a hydraulic power unit, drawworks, and top drive system. And you can see this equipment basically is part of a system which is breaking down into equipment and then sub-assembly. And the sub-assembly components each will have a specific set of data analyzed, and this will produce, after it's run through the analytical software, a set of recommendations and status for its of where it stands. On this slide, you can see the equipment health status. And so this is the output that the maintenance team can see for each equipment. And through these data, he'll be able to predict if anything is malfunctioning, so that he needs to change the time where this maintenance task has been planned, or he can even extend the next overhaul for a later date. So through this screen, this is the type of information that the maintenance team will see, and then the analytics will be updated and processed to move forward and keep the system updated. And again, this is the next analytics type of screen that the maintenance team and the CBM engineer and specialists are developing. So for each equipment, you can observe here on this graph, for example, we have fatigue damage for threads in the low color on one picture. and then another type of fatigue damage below. So all this is run through artificial intelligence analytics through the data IQ platform, and is enabling the teams to develop the models for the CBM maintenance on the platform. So these are just the acronyms that have been used on the presentation. And with that, I conclude. If there's any questions, later we can ask. One of them, which I saw while the others were presenting, is regarding what's the percentage of automation on the platform. So I would say that, today we have covered more than 90% of automation. Basically, everything that we need to be automated actually is automated. We have equipment which will be added to the operations, for example, from other third-party companies, which we're also looking on adding telemetry and sensors, so that this equipment is also added to the scope, and we will be able to include them in this analysis. So not only the equipment which is today in the platform can be monitored, but any additional equipment which is later added as a service on the DPU can also be, if it's an important equipment to monitor, it can be digitalized and added to this. With that, I conclude, and thank you. This is a picture of, again, our part of our team working on one of the drill well on simulator sessions, where they go through the Equinor program, and all the steps are checked against the workflows that have been prepared.
Thank you, Carlos Garcia. I was curious about how much training is needed to have a crew ready to this kind of, for this process. Well, I'm still curious. I believe that we'll have to ask you later. But now, well, you answered the first question from Cabrera. So let's start with some questions from the audience. I have one for Gleber. From Gleber, the PWDA is based on CBR, case-based reasoning.
Excellent question, Pedroso, and excellent question, Gleber. In fact, no, the PWDA software, it's mainly based in hydraulics, mechanical and physical algorithms that represents or better, try to represent all the drilling operation. So we have some kind of digital twin, between quotation marks. We have a digital twin that try to emulate all the operation that we have on bottom hole during the drilling. If some behavior is not totally agree with the simulated behavior, for example, the pump pressure should be increasing and in fact is decreasing, so all this, the simulation will input that some kind of washout or jet problem in the bit is happening and so on. So it's mainly based in mechanical and physical algorithms. But the version 2, we are implementing now machine learning algorithms based on historical data and so on. But the first one is mainly digital twin, mechanicists, and physical modeling. That's it.
Okay, thank you, Gleber. Let's go to another question from the audience. This is from, I'm not sure, well, after I see. to Ramon. Ramon, how many days Equinor expect to gain with the use of this technology? And together with that, let me say, well, I really believe that we need, you need, the operator and the drilling contractors need a lot of investments to apply this technology. So it has to work. So how do you do that? And what do you expect to gain with this investment?
This first one, the number of days, it's a tough one, right? We have not started drilling yet, but what we can say that you have Johan Sverdrup, that the largest development in Equinor today, especially in the North Sea, and we also had modern operations in UK that they have just drilled a well there. And Schlumberger is one of the main providers there, and we were very successful, implementing similar operations that Johan Sverdrup have, of course, a higher level of digitalization, but with the same idea. And we were able to reduce, actually, the drilling well was hugely improved in Mariner, for example. So we have high expectations total well delivery for the next year when we start drilling. And the second question is very good because it gives me the opportunity to talk about the one team approach, right? That's the way we collaborate in drilling well. Because for us in drilling well, this approach, one team, it's as important as the digital initiatives that we have, and that helps us to have the well optimized. The well construction optimization goes beyond the digital initiatives, and we promote shared goals among Equinor, recontracting services companies. We have follow-up meetings together. We have a one common operating model, and this helps a lot to flow the communication a proper way. It's a continuous learning from each other. It's also about empowering people and wanting custom and listen to them. So it is a very important. If you can think, I'm answering kind of in a standard way, but this is really making a difference. This one team approach. So just to summarize it, the way we collaborate with the suppliers in drilling well is just giving them, empowering them, and work together.
Okay, thank you. Let me rephrase the question to Andy. Can you elaborate a little bit about the expected performance improvement using the TWD process?
I can try for sure, yes. I mean, Ramon touched on it in what he said. I think if whichever operator you come from, you look internally at your own non-productive time, our aim is to save all of that, as in with the predictive analytics, the condition-based maintenance, and the sensors that we have that Carlos spoke about. We shouldn't be having rig equipment failures, or they should be very rare indeed. So, if you look at historic averages, I don't, more or less, but ballpark figures, they're sort of 10, maybe even 20% of drilling time is spent non-productive with a rig for one reason or another. So we're looking to save all of that. And if you look at service company non-productive time, then, through human error, equipment failures, because, as Gleber was talking about, washouts are not detected, and you get twist-offs, you have to go fishing to recover your BHA, sidetracks, these sorts of things, then the service company NPT can be upwards of 10, 15%. So again, we're looking to eliminate all of that as well. And on top of those NPT savings, and by now with the rig and the service company, we're in the 20-25% mark. We're looking to make these consistency gains, these efficiency gains through consistent performance with the automation side of things, which again can give you incremental improvement, maybe 5%, 10%, something like that. So, yeah, I'd argue it's not unfeasible that if it takes you a month to drill a well, we should be looking to drill the same well in 3 weeks and save at least 25% of the drilling time in what we're looking to do. And the aim, Equinor, for those of you who understand how Equinor measures performance, they have a concept of the perfect well, which is they look at all of their offset data, and for every section, they look, what is the fastest we have ever drilled that section? And then a well consists of maybe 3, 4, or 5 sections. You build a time depth curve using the best performance for each section from all of your offset data, and that gives you a perfect well. Our aim is to be consistently drilling perfect wells for Equinor, and which will clearly put the drilling performance in the top quartile globally. And our aim is to help Equinor Brazil drill the fastest, most efficient, and safest wells that Equinor drill anywhere in the world. That would be my answer to that.
Oh, good.
And if we fail, it's my fault. So no pressure there.
Okay, thank you, Andy. For Carlos, I have in fact some questions about. Can you elaborate a little bit more about how much time do I need to have the crew trained, to have the certified rig, and how much modification is needed in the rig? This is 3 questions in one, so you can answer everything. It's closed. The mic is closed.
Sorry, Carlos. You can hear me now? Yeah, so we planned originally to be ready around August, September. Obviously, this was before the COVID-19. And we allowed 9 months was the total time to get the all the drilling crews recruited. Remember that we don't have another operation similar to this in Brazil or any other place in the world, in fact. So the total plan to inboarding all the junior crews, make them familiar with all the Schlumberger requirements, and then regulatory training, and then the specific training for the total well concept, which includes all the drill well on simulator, etc., was 8 to 9 months. That was the total time, and that included online training sessions, classes which are both in-house and with a third party, like Rely New Tech is heavily involved on all the trainings that the crew have to go to. And then we have trainings on the simulators, both in Macaé and in Katy in Houston, Texas. We had personnel go to Norway before the platform sailed to get familiar with the equipment. So each category had a different plan. The plan was suspended in March because of the COVID-19 situation. We had very little progress because we are only managing to do the online training right now. But a lot of the training is you need to be either on a training center or on the platform. So hopefully we'll retake this soon and move forward. Another aspect that we're doing is what we call COMAS, which is competency assessment. So every person does like an online assessment of his own role. And then an assessor will interview this person and do an evaluation at the platform if he is, what are the gaps of his function to be, ready for the job. So that's something which we're doing internally with a senior drilling superintendent, which is in charge of running this program. So yeah, the training program is quite complex, and it's a total of 9 months to be able to complete it. Yeah.
sorry, let me use your answer and complete with a question of the audience that is, all this application that you showed us, I believe this question is for you, Carlos, and you, Andy. All this application that was showed is based upon a lot of data and a lot of modifications, and you told us now based upon intensive training and well, a quite complex process. Is there any space for small companies to use that? And my question, I am from a small company. How do I start this process?
I'll give this a go first, Carlos, if you like, and you can follow up.
Okay, please go ahead.
So can it be used by smaller companies? Yes, is the answer. I mean, everything that we do, everything that I showed you on the drill plan and drill ops, whilst it's a service and included as part of the contract for Equinor, is also able to be sold as a service or as software from Schlumberger. So any company can buy a license for drill plan, for instance, and have their own well engineers learn how to use it. It's pretty straightforward and fairly easy to learn. I've not learned it myself, but I'm told that's the case. Or we can provide it as a service. You know, if you want to design wells, but you don't, if you're a company that doesn't have its own well engineering capabilities, then we can also provide well engineers. So we can either sell you the software, you run it yourself, sell you a license, or provide the engineers to use it to give you the digital drilling program. Implementing the drill ops side is a little more complex because it requires, well, it doesn't require, but there are aspects of it that make it more efficient if it interfaces with the rig control system. In Equinor's case here, the rig control system is also designed by Schlumberger, by Cameron. So we've obviously designed our software to talk and communicate to that. If it's, we have interfaces to other third-party rig control systems. MH Worth is one of them, and a few others. So our software can sit on top of a third-party rig control on a third-party rig. So if the likes of Diamond, Transocean, Ensco, Seadrill, somebody like that turned up with a rig control system that interfaced with our drill ops system, then they would plug and play to some degree. But even without that, even without the automation and the orchestration side, if there was no rig interface, the drill ops advise side would still work, because if the rig had Schlumberger services on it, then those sensors from our services would feed into drill ops, and then the whole cloud solution, the analytics and the monitoring aspect would still work. So yeah, the whole thing scales to some degree. And also it's written on an open architecture platform. It's written on something called Delphi. And that has the ability for people's own software. So if a small company, you had your own algorithms for doing things, your own intellectual property, proprietary knowledge, you could keep that hidden from us and keep it for yourself, and through an API, an application program interface, send your data to our software, or retrieve data from the sensors that we have, run it through your algorithm and push a result back into the system. So there are ways of making your own systems plug and play, and the whole thing is scalable depending upon which services or which personnel or which activities that you're doing. Hopefully that answered the question. But look, Carlos, if you have anything else to add.
Well, today digitalization is quite a broad word, right? So today even we had recently a problem with communication with crews, and we developed our own app, you know, on mobile phones to be able to communicate with them at basically zero cost. So it depends what you're looking for. Regarding this technology like that we're using for the condition-based maintenance, is a lot of things that come together under one system. So for example, the artificial intelligence analytics is done by a company called Data IQ, which you're invited to look them up in the web, and they're one of the companies which help develop artificial intelligence for small and big companies. Obviously, if you need expensive equipment with PLCs, etc., then the costs start being high. So it depends what is the scope of what you need to digitalize, that you will be having a low high cost. But I think there is opportunities for small companies to work in this digitalized environment.
Okay, thank you. Well, we'll have to start someday. Gleber, I was very curious about that smart contract and blockchain. Could you talk a little bit more about that?
Hello. Yes, for sure. In a brief words, what I can say, a smart contract, in fact, is an algorithm, is a computer program that will manage and will handle many parts of a contract agreement. For instance, the example that I said before, I want to pay for when I use a pump, for example, cement pumping in the rig. So I put sensor there, and the sensor, when start pumping, the sensor will send the signal to the smart contract and say, okay, the pump is on, and start paying for the flow rate. So the sensor is acquiring the data, send it to smart contract, and the smart contract are recording this data and preparing to pay. One big issue about smart contract is about taking the confidence, how we can improve the confidence of the system related to this agreement. For this situation, we can use the blockchain technology. The blockchain technology is a technology that will handle data, will store data in a safe manner, almost impossible to change. For this reason, this pair, smart contract and blockchain, is a very good agreement, is a very good situation, because one of them tests reliability to the smart contract. For this reason, the blockchain is one of the most, technology that can replace many instances of related of reliability or agreement. Some people said that the blockchain can replace, for example, here in Brazil we call cartório. I don't know what's the name in English, but cartório, everybody knows.
I don't know if they have that.
Yeah, but that's the point. Maybe blockchain can replace the cartório because it can provide us a safe manner.
A public blockchain, so?
Yes, a public blockchain. If we are talking relation between companies, we can use a private blockchain. But if we are talking about a public system, for example, cartório, we can use the public blockchain. That's it.
Okay.
In a few words, that's it. The blockchain is a cryptography technology that can guarantee you a safer, guards of the data, in general terms.
We have a contribution from the audience here. Cartório is notary office.
Good, thank you.
Thank you, Rafael. So, one question to Ramon. what's the main challenge to implement the TWD process?
Just a second, yeah. The main challenge, there are a lot of challenges, I would say, right? Because we are always very excited to talk about innovation, new futures, but however, to successfully deploy a new way of working requires that we follow good management of change. Right? It's imperative to reduce a minimum the early failures and boost the natural learning curve. And I think Andy and Carlos touched upon that. If you have a high level of non-productive time, it can kill the idea. So the business case and positive business case based on assumptions, and this needs to be carefully implemented. And the idea has to reach a certain maturity level to be implemented in a holistically way. Another thing it's challenging, in Peregrino, we've been discussing a lot, is this proper commercial model. This will definitely help to stimulate new technology. We have observed in our industry that the contracts are priced to time-based drilling services with too few incentives for investments in automation technology. It somehow prevents the use of some newest breakthrough ideas, but I see that this has been changing rapidly, And the one last point that we discussed a lot is I see also a challenge the operator along with the contractor have to give the required capacity to all involved.
I believe that we lost Ramon. Ramon? Okay. Yeah. Well, I would like to thank Ramon, but we are coming to the end of this webinar. We passed 10 minutes from the time. So I would like to ask you for the final remarks, starting with Gleber. Can you make your final, summarize and final remarks about the well 4.0?
Yes, I would say the most important aspect in this new technology area, as I said before, is the people, right? Training people, new skills, as I said, data science, data engineer, blockchain developers. So I would say for the young guys there in internet, the people that want to study some area, maybe invest your time dealing with new technology should be a good approach to the next few years. For sure, we'll have a lot of necessity to bring these guys to the oil and gas company. So that's my final remarks, and thanks again to SPE and Petrobras for the opportunity to be here. Thanks e boa noite a todos.
I believe that Ramon is still off. We had a lot of questions yet here, but unfortunately, we don't have time to answer all. Well, you leave your contact, maybe the audience can contact you for the questions. Andy, would you like to take 2 minutes to summarize and final remarks?
Sure, thank you, Carlos. We're here to talk about resilience in the offshore oil industry, and resilience with a low oil price fundamentally comes down to saving money. Saving money obviously has a limit in terms you can't just squeeze contracts and expect that to continue. And if people aren't making money, then really there's no money to invest or improve what we're doing. So I think the drive has to become resilient through cost savings, but sustainable cost savings. And those cost savings aren't just through squeezing contracts. It really comes down to improving how we drill wells and therefore saving time. so that the costs are reduced, not just the contract values, let's say, which is the subject of what we've been talking about here. It's about well construction optimization. And the method we're using, as you've seen from our contract with Equinor, is to align with Equinor, work with them as one team, align and motivate ourselves with the same end in mind, hence the lump sum contract. So if they make money, we make money. If they lose money, we lose money, and we're aligned in that regard. So it's about contractual alignment. It's about having enough of the services to make it worthwhile, because in the digital age, everything is about integration, and it's hard to integrate if there's multiple stakeholders and lots of different players. So reducing the number of stakeholders allows for internal integration. So therefore, it's really not just about being fast. Being fast is no good if you hurt people. So the number one priority always has been and remains being safe. And when you speed things up, things are likely to become unsafe, in fact. So it's not about rushing, it's about becoming efficient and reducing the length of time to drill in a safe way through efficiency, through reliability, and primarily through consistency, just doing repetitive tasks in as optimized a way as possible and removing the element of human error which computers allow you to do. That's it. I'll stop there.
I believe that Ramon is back. We are making the final remarks. Can you summarize your thoughts and make the final remarks, Ramon?
Of course, sorry about that. I dropped off here. I'm not sure if you heard my last statement. We were talking about the challenges in implementing
yes.
DWD new models. But I hope that you heard. If not, but it was a pleasure to me to be here, and I enjoyed very much. So I hope that we could, share some of the initiatives that we've been working on, and if anyone has any doubt or question that's remaining from the audience, I'm available. We can touch base and discuss it.
Thank you. Garcia would like to.
Yeah, just some words on automation. When we 15 years ago thought about automation, at least from a drilling contractor perspective, we were wanting to change out human force, a person on a rig, which could potentially have an accident, for like a robot figure. But we never imagined that the technology would evolve so much that today, digitalization and automation means, having a lot more access to information, and a lot of the information is how this equipment is working and functioning and coming together. So there's a vast field that opens up when you have all this information in your hands. So it's not to do with substituting people with robots. Is understanding how equipment works through this information. And in fact, we have seen that the amount of people on the teams that have to be involved are maybe even greater than they used to be in the past. But we have a lot more understanding on how this technology works, and we can prevent accidents and events with this information. So it's quite a new subject, I would say. This condition-based maintenance is something new that we're implementing with Equinor on this project, and we're quite excited to see where it leads us. So yeah, happy to be part of this project.
A question about that: is there any published work yet about this? This is a question from the audience. Is there any published work? Not yet.
Internally, we have some experience with the ROFO rigs. That I have not seen yet the results. I can search that and forward to you, Carlos, because internally we don't have a lot of information. On the first step was on the ROFO land rigs. We had a certain amount of this condition-based maintenance starting to happen, but it didn't reach the stage 3 that we talked about. So no, we still don't have a lot of data to be able to publicize what have been the results with this type of maintenance.
Okay.
But I will search and I will send you more data on this. Yeah.
Thank you, thank you. So we come to the end of this webinar. Just summarizing, the main purpose of discussing this is because we are talking about the resilience, and I will repeat the words of Andy, that we using this technology is a matter of increasing efficiency, increasing safety, and hopefully reducing costs. And that's what we need to do. And I really believe that these words, as I said at the beginning, I'm sure that this process will be the future. We are talking about the well of the future. It's not just question of automation, as you said, but is a whole process of using all the information at the right time. So I really believe that in the very near future, we will be very used to this technology, and we would question ourselves, how could you drill wells without this technology? So I thank you once again, Gleber, Ramon, Andy, and Garcia. And thank you to the audience and the very interesting questions. I'm sorry we had no time to answer all of that, but you can ask directly to the panelists. I will pass the words to Mauro to finalize the webinar. Thank you very much.
Bem, boa noite a todos. Primeiro, eu gostaria de agradecer ao Pedroso, né? Realmente foi um excelente trabalho, Pedroso, aos panelistas. Realmente conseguiram segurar o público até o final, né? E eu imagino que esse webinar foi o que maior teve a participação do público, né? Você vê que várias questões foram feitas, a gente nem conseguiu terminar no prazo, ficaram perguntas para serem respondidas depois, né? Então, agradecendo aí ao público pela participação e tudo. E lembrando ao público, já que estamos participando, né, o SPR, principalmente da Seção Brasil, nós temos hoje 1.932 filiados, sendo 535 profissionais e algo em torno de 1.397 dos capítulos estudantis. O SPR da Seção Brasil apoia 11 capítulos estudantis, tá? E nós todos trabalhamos com voluntários, precisamos de mais voluntários, precisamos de gente participando, né? E para você se tornar um membro do SPR, você tem que ficar filiado ao SPR, só entrar no site e se tornar um filiado ao SPR. Tá? Lembrando o seguinte, no mês de setembro, quando você entra em setembro, já conta a anuidade para o ano que vem. Tá? Então, você fazendo agora, você não está pagando para 2020, por exemplo, você já está pagando para 2021. Bom, devido a toda a situação atual, né, existe um desconto, normalmente é $90, o SPR agora está cobrando a unidade de $50. Isso aí, se você quiser, você pode pagar $150 e já vale para os 3 próximos anos. E se você está desempregado, tá, não tem problema também. Existe uma opção em que você poderia continuar até filiado ao SPR durante 2 anos, isso pode ser até prorrogado, né? Então, você não precisa pagar anuidade. Se você é estudante, a gente quer também, a gente já participa em 11 capítulos estudantis com quase 1.400 estudantes, seja de mestrado, seja o estudante que vai ser graduado, seja em qualquer engenharia, né, ou arquitetura, o que seja, química, tá? Se você está fazendo doutorado, você pode muito bem se filiar ao SPE e é gratuito. Tá? Se você é estudante, você pode se filiar gratuitamente. E mais, se você se filiar quando estudante, quando você passar para ser um profissional o primeiro ano, você não paga. Tá? E se você não se filiou antes e passa como profissional, no primeiro ano você paga $10, certo? Então, você vê que o objetivo não é arrecadar nada, é simplesmente passar o conhecimento, aumentar a interação entre os profissionais e, obviamente, ajudar todos os profissionais que precisam entrar nesse mercado, tá? Para tentar aumentar aí o nosso conhecimento no mundo do petróleo. De novo, nós estamos aqui com 5 excelentes profissionais, todos 5 fizeram esse painel e com certeza deve ter sido o melhor painel de todos. Bom, agora tem um grande desafio, o próximo vai ser semana que vem, vamos ver se o próximo consegue bater esse, que na minha opinião deve ter sido o melhor deles. Tá? O próximo vai ser no dia 29 de setembro, abordando otimização dos projetos subsea. Tá? Então, espero vocês todos na semana que vem, no mesmo horário, começando às 6 da noite, na semana que vem. Tá? Boa noite a todos.
Um último agradecimento, Mauro. Eu gostaria de agradecer o pessoal do backstage, que é quem faz essa roda girar aí. Muito obrigado ao Max Tocantins, ao Youssef e à Jennifer, que nos apoiam aí nesse evento. Mais uma vez, obrigado a todos. Boa noite.
Boa noite.